Alright, this lesson deals with the distributive property, and we're looking at two-step equations, or multi-step equations actually. We're going to put the distributive property, some fractions, maybe some decimals, variables on both sides, constants on both sides. So I mean, it's just getting really complicated. We're just going to take care of this stuff one piece at a time. Before we do that, I'm going to go over a little bit of review here for the distributive property. And when we're looking at the distributive property, if this was just 3x, 3 with an x in parentheses next to it, you would just multiply 3 by x. So what we're going to do is realize that we have to multiply everything inside by the 3 that's on the out. So even the most practiced mathematicians will make little marks and drawings on their work to remind them of the processes that they're supposed to be going through to get their answers. And that's what I'm doing here. I'm just marking both of them. Now the 3 times the x is going to be 3x, and then my 3 times the 4, we're just going to distribute both of them. We're going to put that 4 right back here. And so when we're looking at our answer, what we should realize is this is really 3 times what's inside. So this would be 3x's and then 3x's and 3 4. So if we were to look at this and add everything up, it would be x plus 4, x plus 4, and x plus 4. And then we would have 3 of those. X plus is 3x, 4 plus 4 plus 4 is, well, looks like I made a mistake because this shouldn't be a 4, it should be a 12. Okay? We have to remember that when we're taking this through here, we're multiplying the first one, we're also multiplying the second one by the 3 as well. So, the biggest mistake that people make is multiplying by the first one and then just marking the second one down, just like I did before with my 4. We don't want to do that. We want to make sure that we do both. So sometimes instead of going to the first one, what I'll do is I'll do the one in the back first, and then it's kind of like painting your way out of a room, or mopping your way out of a room rather than into the room. You end up at the door with the wet mop, and then you just put the mop aside and you walk out. You don't end up mopping yourself into a corner and then having to walk through the wet floor. So we're going to go to the back of the room, do this one first, and then forward. Before I do that, you can see that this one is 3x plus 12 is my answer up here. This is going to be the opposite of 3 times x plus 12. This one's going to be the opposite of this, 3 times this. This is going to be the opposite of both of them. And down here I have one that is the opposite of what's inside. So what we're looking at here is if we can check our answer knowing what 3x plus 3x and 3 times 4 is, and our opposite if we just finish this and then look back at this original answer. So I'm going to go backwards this time. I'm going to go to the back of the room, which is a negative 12, and then I'm going to come back to the first one, which is a negative 3x. And I said before that this was going to be the opposite of 3 times x plus 4. The opposite of 3x is negative 3x, and the opposite of 12 is negative 12. It worked. So what we're going to do is look at both of these. Negative 3 times x is a negative 3x, and then negative 3 times a negative 4. So this is the opposite of 4 times 12, which is going to be a positive 12, because negative times a negative is going to be positive. 4 times 3 is always 12. Here, it's the opposite of a negative, opposite 3 times a negative x and a negative 4. So here we have the opposite of an opposite, that's going to be positive, the opposite of the opposite, which is also going to be positive. So this is going to be 3x, because x times 3 is always 3x. Negative times negative is positive. Negative times negative is positive, and 4 times 3 is 12. Okay. Here on this last one, we have the opposite of x minus 4. Now many people struggle with this because they don't realize that there is something associated with this negative that is a number. Okay? This number is a 1 on the outside of this thing. This way, what's going to happen here is we need to make everything the opposite of what it is, because that's what this means. We also don't want to change the quantity or the value of these numbers, so we need to keep their identity, and the only way we can keep their identity is by multiplying them by 1 which is the multiplicative identity property, and if we want them to be opposite, we must multiply them by a negative. So a negative 1 times x is going to be negative x, and a negative 1 times a negative 4 is a positive 4. Alright, so there's our review section of that, and now what I'm going to do is go through 3 problems that deal with exactly what I was just talking about. So we're going to look at this first one here. We have variables on both sides, and we have a difficulty of the distribution going on the left side of this equation. So I'm going to make my little marks. 3 times x is 3x. 3 times a negative 5 is negative 15. And then I have my 1. 2 plus x. Now we have variable terms on both sides. We have a constant term of a 2 over here, a constant term of a negative 15 over here, and a constant term of a 1 on the left. We should combine these into one idea so that we don't have to make a 0 pair with the 1 and then a 0 pair with the negative 15. So I'm going to change this into 3x minus 14 equals 2 plus x. Well, the first thing I should have done was drawn my line down the middle. Always should do that so I can make sure that I'm balancing the sides. Now, we have a variable term on both sides and constant term on both sides. We would like this constant term to be part of this one so that we can gather all of our constants and gather all of our variables, and then we can solve for our x. We can't do that until we have them separated on sides, on each side. So I'm going to make a 0 pair with this 14. There's my work line. 0 here equals, here's 16 plus x, and this is 3x. And now I have a variable term on this side and a variable term on this side, so I'm going to combine my variable terms by making this a 0 pair here, and again, there's my 1. 3 minus 3x's minus 1x would be 2x's equals 16. I need this to be 1x, not 2, so 2 divided by 2 is a 1. 16 divided by 2, because whatever I do to the left, I have to do to the right. X equals 8. Here we go. And then I mark my answer with a rectangle. Okay? So I have a lot of things going on here. I did my distribution. I made a 0 pair to move everything over to the other side. I moved this one with a 0 pair, and then I made a 1 to actually solve the problem. Okay? The second part of this looks like this. My second example, I'm going to draw my line, okay, and then this has nothing changing over here, but this one does, so I'm going to just rewrite this side. 5 minus k equals, and then a negative 4 times k, negative 4 times 1, because I have to put it to both of them, is negative 4 minus 3, okay? Now, what we have variable terms on both sides, constant terms on both sides. We need to put the terms that are like each other together. So we don't want a 0 pair with the 4 and then a 0 pair with the 3. We would like to combine them and then do it at once. So let's remind ourselves that negative 4 minus 3 is really negative 4 plus a negative 3. And this becomes negative 7. Negative 4k minus 7 equals 5 minus 7k. We could make a 0 pair with either one of these and move them to the other side, but what I'm going to do is I'm going to make a 0 pair over here. Because if I make a 0 pair with this, with the 7k, 7k has a larger absolute value than, or a greater absolute value than the negative 4k, so when these are combined, I'm actually going to have 3k, and now what I have is a positive number on the front of my k, or a coefficient is what we call that. We have a positive coefficient on k, and now when I do my division at the end of this problem, I'm not going to have to mess around with whether I divide with a negative, and if I'm dividing a negative with a positive, or positive with a negative, and don't have to mess with that at all, because it's going to be division with a positive number, and that does not change the sign of the result. whatever I'm dividing, like when I divide this by a 12, this is going to be 12 over here when I divide it by 3, and the 3 is positive. If the 12 is positive, it stays positive, the answer does, and if it's a negative 12, then it just stays negative. So the positive division doesn't change the sign. And that's really what we're doing here, is trying not to complicate things too much. This is a two-step equation. Everyone in the room knows how to solve a two-step equation, so we're just going to make a zero pair. Here's my zero pair, equals my 3k over here, and this is 12, and there we go. I'm going to divide 1, zip, and 4 equals k. And there we are. There's my answer. All right, so this last problem has a difficulty with it. Not only are we distributing over here, we're also distributing a fraction on the left side, which can be really, really messy until we realize, let's just get rid of the fraction. If I was to distribute the 3/4 over that would be a 3/4 x, and then 3/4 times negative 13, which would be a negative 39 over 4, and then we would have a negative 18 and a negative 2x over here, and now we're dealing with fourths, and we have to mess around with all that, and we just don't want to do that. What we would rather do is take care of the fraction first. So what I'm going to do is I'm going to multiply both sides of this equation by 4. So I'm going to multiply what I have to do over here to get rid of that fraction. So this side gets multiplied by 4, so does this one. Okay, now I'm going to address this in just a minute. Over here what's going on is I'm not going to multiply the 4 by this and by this, because this is kind of protected by the parentheses. You really can't do anything inside there until you distribute. So what we're going to do is we're just going to put these two factors together out here. We're going to put those together as it is. So 4 times 3 is 12, divided by 4 is going to be 3. Well, the 4's are going to cancel to be a 1, and that's why we did that, is to get rid of that. And this side over here is going to end up being 3 times x minus 13. Here's my line. Woo! Ooh, that was crazy, man. Finished my stuff there. And then what's going to happen is over here, the 4 and the negative 2 and the 9 minus 7. So really there's 3 numbers that are being multiplied over here. What I'm going to do, instead of multiplying the 4 by whatever this mess is, I'm going to do what I did over here. I'm going to bring the 4 up to the front, and it's going to be negative 2 times 4 over 1 times 9 plus x. Okay? So instead of multiplying every single piece by this, that's going to happen anyway, because once I multiply this by this, the 4 and the 2, then the 4 is going to be in there, and it's going to go into the 9 and the x anyway. But we don't want to do it here and here, because then it's just going to mess everything up. We want this thing to be simpler. So I'm going to rewrite this side again. And then the negative 2 plus times the 4, negative 2 times the 4 is actually going to be negative 8. And then we have 9 plus x. I'm going to multiply my 3 by x, which is 3x. 3 times 13 is, whoop, that's supposed to be negative. What am I doing? 3 times a negative 13 is negative 39 equals negative 8 times 9 is negative 72 plus negative 8 times x is going to be negative 8x. Right? Make my zero pairs because I need to start moving things around. I could subtract 3x from this side, but then I'd subtract 3x from that side, and it's negative 8 minus 3, which is negative 11. So what I'm going to do instead is I'm going to do this. I'm going to add 8 to both sides, and this is going to make 11x minus 39 equals negative 72. Here's my zero pair. And I have a positive coefficient on my variable for my division. Make a zero. I've done this before, and this always, I don't know what it is with this thing, but I was like, let's just make this a 40. 72 minus 40 would be negative, which is negative 33. 11x equals negative 33. Now, need my 1, zip, and we'll 1 over here, and this is going to be x equals negative 3. Right? And then here's my answer. So there's a number of things that I did here. I took the time to get rid of my fraction beforehand so that it wouldn't be too much of a problem And I would get rid of it before I actually started trying to do the rest of my. Hey, get out of there! Get out of there! What are? Nope! Stop that! I'm gonna get you. I told you to leave my pens alone. Anyway, I gotta go, guys. Gotta deal with this. Seems to be an alligator in the room.